Okay, so remember our A is still our initial value. It's our y-intercept. Okay, that's not going to really change around. Bless you, Karen. Okay, and our B is our growth or decay, depends on what it is, factor. Okay, so when B is greater than 1, it's going to be a growth, but when it's between 0 and 1, it's going to be a decay. So when we think about this B, to find B, we're going to do as 1 minus R if it's a decay, and our B can also be 1 plus R if it's a growth. So remember, the R stands for the growth or decay rate. In word problems, it gives us the R for the most part. We start with an account of $500 and has an interest rate of 6% compounded yearly. Does anybody know what compounded means, Rebecca?
Like it gets bigger every year.
Gets bigger every year.
6 one year, the next year it'll be 12.
Very good. And then they use 12 to figure out the next number and so forth. You always want compounded interest when you're putting money in the bank. You have to do it on a loan too. But anyway, so how much money is in the account after 3 years? So is this going to be a growth or decay? If I'm putting investing money, is my money going to go up or down? If it's just going to the savings account? Up, right? So it's going to be a growth. So I'm going to just circle growth. You can write it if you want. All right, how much is my initial value? 500. Very good. Okay, now I have to find my growth or decay factor. Okay, so I'm going by 6%, but we're going to want to deal with this in decimals. So what is that going to be? 0.06. Okay, so now I've got to want to find that factor. I really should have written rate. So in my number, I'm going to do, to find my B, I'm going to be 1 plus 0.06. So my total function, f of x, equals 500 times, we can write that or we can do the math to it, 1.06 to the x power. Is everybody good with that being the function? Okay, now we have to actually do the problem. So what number am I going to plug in for x? 3. I'm going to plug that in. It's going to be in that account. Rebecca?
I got $595.51.
Yeah, we're going to go crazy. 51 cents?
Yeah.
Okay. And then we can say after 3 years. So a little label. Okay. All right, so from 2010 to 2018, a city has a 2.5 annual decrease in the population. If the city has 2,950,000 people in 2010, determine the city's population in 2016. So we've got to think about this. Is this going to be a growth or decay? Decay, and why do we know it's going to be decay? Because it says decrease. Very good. So the initial value, what are we starting with? 2,950,000. Again, do you see why a calculator is so nice with these? All right, now our rate. So we think here we have to find our rate by, am I going to do 1 minus or 1 plus here? Minus. And we have 2.5%. So what is that as a decimal? 0.025. So 0.025. So we have to take 100%, and we are going to get 975 thousandths. Everybody good with that? And then I'm going to write my model. So I'm going to do y equals my 2,950,000 times 0.975 to the x power. And then we're going to actually do the math. And then what number are we going to substitute in for x? So think about, so 2000 to 2006. How many years do we got going on there? 6. Very good. So when we do our math, 1, 2, 3, 6. And since these are people, do we want to have a decimal here? No. Okay, in 2016. Buy a car for $8,000 that depreciates at a rate of 11% a year. What does the word depreciate means? Decrease, goes down. Appreciate means to go up. At a rate of 11% a year, how much is the car worth after 5 years? So is this going to be a growth or decay? Decay. So I have to find my B. I know I'm going to do 1 minus 11 hundredths. Okay? So my whole function, I'm going to have my f of x equals 8,000 and 89 hundredths. And what is my exponent going to be to? The power of 5. And I'm going to get $4,467.25. Is everybody good with finding that B? You gotta look with your rate. All right, our next step. You started an account with $2,500 and it has an interest rate of 6.5% compounded yearly. How much is in the account after 7 years? So my initial value, am I going to be a growth or decay? Growth. So I'm going to have my initial value of $2,500. All right, so I know it's a growth, so I'm going to be 1.065. So I add 100% to that. And then what's my exponent going to be? 7. And I would get $3,884.97. A newly hatched channel catfish typically weighs about 6 hundredths of a grams. During the first 6 weeks of life, its weight increases about 10% each day. Write a function to model the catfish after 6 weeks. So here's our first thing here. We have 6 weeks and we have day. So what do you think we want to kind of convert what to what? What do you think would be easier? Weeks into days. So how many 6 weeks would turn into how many days? 42 days. So we're going to, that's our first thing. Our labels aren't going to be the same. So they have to match up. So what does this catfish start out with? 0.06. F of x. All right. Am I growing? Is this fish growing or decaying? Growing. I hope it's not decaying. That would kind of be gross. But I guess something can start out. Anything start out big and then get smaller as it gets older? I don't think so, right? It's possible, but what? I don't know. All right, we'll talk about this. And then what's going to be my exponent? 42. Okay. And then we can put that all into our calculator. And then I'm going to just round this to the hundredths. I'm going to get 29 grams in 6 weeks.